Hello, geometry scholars. So our first lesson that we're going to do before we even jump into any new geometry is we're going to review equations. I want to make sure that you guys have a solid understanding on how to solve equations before we jump into anything that's going to require you to pull those skills back out of your memory bank. So we're going to study this. We're going to review this. This is what you studied last year in Algebra 1, and you would have even started in 8th grade. So let's make sure that you guys fully understand how to solve equations. And remember, when we have synchronous learning times, you can ask me questions and get better answers and clarification if you don't remember these skills. Okay, so big saying for today, the big thing we have to remember is variables on one side, numbers on the other. Variables on one side, numbers on the other. Okay, so that's going to be our little key phrase for us to remember how to do this. Okay, so simplest steps that you can think of whenever you're solving equations is to isolate the variable using undo operations or the inverse operations, and then check your answer. Okay, so let's just try these simple ones first. Okay, so first thing we want to do is we want to isolate the variable. So we want to get this x by itself. We need to get the x by itself. So we're going to get the x by itself, then we need to get this plus 8 to the other side. So we want to get letters on one side, numbers on the other. So we want to get that number to the other side. It's a plus 8, so we're going to do the inverse operation, which is minus 8. Hopefully you remember this. We're going to subtract it or do negative 8, and what we do to one side, we have to do to the other. So we're going to subtract 8 from both sides. That's gone. I'm left with x equals negative 5 minus 8 is a negative 13, and that one is done. That is your answer. Okay, so if we're going to check it, we won't check everyone today, but I'm going to show you how to check it. Or on the video, we won't check everyone, but I want you to make sure that you check your answers especially when you're not using a calculator or have one at your hand. So what we do to check is we're going to plug that negative 13 equals x. We're going to substitute that x value back into the x spot. So we're going to say, come over here, negative 13 plus 8 equals negative 5. Is that true? Negative 13 plus 8. They're different signs, so we subtract and take the sign of the bigger, so that does give us negative 5 equals negative 5. Checks out. Okay, so that is it. That's solving equations using undo operations and then to isolate the variable. Okay, so let's keep working on some other skills and build our way up to some of the harder ones, because I'm sure you're like, well, that's an easy one. What about the hard ones? Okay, so let's get there. So let's look at this next one. 5n equals 35. Well, when two things are squished together, a number and a variable are squished together, then that is the operation of multiplication. And the opposite of multiplication is, hopefully you said division. So we're going to divide both sides by 5, whatever squished with your variable. So the 5's go away, this leaves us with 1, and then we have 1n equals 35 divided by 5 is 7. And that's it. Okay, so let's look at this next one. So there's two ways we can do this. It's got 4x over 7 equals negative 3. We're going to look at this like a two-step equation, but for those of you that might remember this skill, this is like a fraction. We could flip it. We could multiply by the reciprocal, so we could flip it and multiply. But let's just do this as a two-step equation. Let's get rid of that bottom part first, then we'll worry about the top. So I want to get the term with the variable by itself. So I'm going to undo this divide by 7. So the opposite of division is multiplication. So I'm going to multiply both sides by 7. So 7 over 7 cancels. Then we're left with 4x equals negative 3 times 7 is a negative 21. And now I need to get that x by itself. So I got the term by itself, but now I need to get this x by itself. So I'm going to divide by 4. And I'm left with x equals negative 21 over 4. That doesn't simplify, so we're just going to leave it as a fraction, and that's your answer. Okay? So let's look at this other two-step. So let's review some vocab here. So this has two terms on this side of the equation. So in an equation or an expression, then the pieces of an expression that are separated by addition or subtraction are called terms. So what we want to do first is we want to isolate the term with the variable. So the term that's squished with the variable, that has the variable attached to it, so in this case is 9x. So I want to get rid of that plus 8 first. So I'm going to move that 8 to the other side. To move a plus 8, I'm going to subtract it. So that's gone, and I'm left with 9x equals 35 minus 8 is 27. And remember, guys, you have calculators on your phone for this little simple math. You can definitely use your phone for those kind of equations or those kind of facts if you can't remember them off the top of your head. Okay, so then we're going to get the x by itself now. So we got the term by itself, now the x. So we're going to divide by 9, and we get x equals 3. So let's practice our checking skills on this one again before we move on. So we're going to plug that x back into the x spot. We're going to substitute it in to check. So we're going to go 9 times, so when we substitute, we're going to slap down parentheses and replace the value with the number we found. 9 times 3 plus 8 equals 35. Well, 9 times 3 is 27, plus 8 equals 35. Well, 27 plus 8 is 35. Oops, 35 equals 35. Check. Okay, so let's see what happens when we get a little more complicated. Okay, so it says, how do you solve multi-step equations? So the first step to solving multi-step equations is to remove all the parentheses by using the distributive property. So we're going to hippity-hoppity, distributive property. Okay, so then we're going to combine like terms on each side of the equation. So one side, check the other, make sure everything's combined. Then we're going to perform our undo operations to isolate the variable. And this little box right here is a little reminder for you. It says, what do you do when you have variables on both sides? Many students pretend the equal sign isn't there and combine like terms. Wrong! You must use the addition or subtraction property of equality, those undo operations, to get the variables on one side. So you're going to get variables on one side, numbers on the other. Variables on one side, numbers on the other. Okay, so let's look at this first example. Is there anything to distribute? Are there parentheses? No, so we don't have to worry about that. Next step, we're going to combine like terms on each side. So I'm going to look at this first side. Are there any terms that I need to combine? No. 8x and 2, those are not like terms. That has an x, that one doesn't. How about the other side? Nope, nothing to combine. So then I'm ready to move on, and I'm ready to move letters to one side, numbers to the other. Variables to one side, numbers to the other. Okay, so personally, I like to move my variables first, the term with the variable. You can move numbers first if you prefer. Okay, that's not a problem. You'll get the same answer whichever one you move first. So I like to look at this, and I want to say, look at my variables, terms, and it's 8x and 14x. I like to move the smaller one personally, but no matter which one you move first, you'll get the right answer. Okay, so 8x is the smallest one, and that's a positive 8x. So I'm going to use the addition or subtraction property of equality. I'm going to undo a positive 8x with a minus 8x. And I'm going to line it up underneath my other x term. Okay, so then 8x minus 8x, whoop, that's gone. I'm left with 2x equals 14x minus 8x is 6x. Drop the minus 7. Okay, so I got my variables on one side, so I want to send my numbers to the other. So I want to move that minus 7 to the other side with a plus 7. That's gone. So remember, when we move under the equal sign, we have to do the opposite operation. So then 2 plus 7 is 9 equals 6x. Then we're going to divide by 6 to get the x by itself. 9 over 6 does not completely simplify, but that is a fraction that we can simplify. Both 9 and 6 can be divided evenly by 3. So that would actually simplify to 3 over 2 equals x. Hopefully you remember those simplifying fraction rules. Okay, let's look at the next one. All right, first thing we have to look at is, do we have to use the distributive property? Are there parentheses that have something squished to it that we need to distribute? Yes, there is. Right here, this 3 has to be distributive into these parentheses first. So we're going to hippity-hoppity, distributive property. Okay, so then we're going to drop everything else and just distribute. So positive 3 times a positive 4x is a positive 12x. Positive 3 times a negative 5 is negative 15 equals negative 40. Okay, now I'm going to look on each side of the equation and combine like terms. Are there like terms over here? Oh, look, there's 2 that have an x. So that means that before I can move on, I need to combine my like terms. Okay, so negative 7x plus 12x combines to give me 5x minus 15 equals negative 40. Okay, now I'm ready to get my letters one side, numbers to the other, isolate the terms. This is back to a two-step. My x's are all on this side, so I want to move this negative 15 over with the other number. So a negative 15 or a minus 15 moves underneath the equal sign by adding it. Add 15 to both sides. That cancels, and I have 5x equals negative 40 plus 15 is a negative 25. Then I need to get the x by itself by dividing by 5. And I get x equals negative 25 divided by 5 is a negative 5. And that's your answer. And again, on all of these, if you weren't sure, you could plug that x back into all the x spots, just slap down some parentheses and simplify, and you'd be able to check your answer. Okay, let's keep working. All right, so the next one. 4 times x minus 7 equals 8x plus 6. So there are some parentheses with something squished on the outside. So the first thing we have to do is a hippity-hoppity distributive property. So we're going to send that 4 into those parentheses. 4 times x is 4x. 4 times negative 7 is negative 28 equals 8x plus 6. And now I need to check. Is there anything to combine on either side of the equation? Any like terms? No, not on this one. So now I'm ready to send my variables to one side, my numbers to the other. So I'm going to take this smaller x, this positive 4x, and I'm going to subtract it to move it to the other side. That's gone. I'm left with negative 28 equals 4x plus 6. And now I need to send my numbers to the other side, so that positive 6 needs to go to the other side, so I'm going to send them over with a minus 6. Negative 28 minus 6 is negative 34 equals 4x. Then I'm going to divide by 4. Negative 34 divided by 4, again that doesn't divide evenly, but it does simplify to a negative 17 over 2 equals x, or if you gave me the decimal, I'd still give you the right answer, or I'd still give you credit for that on this case. Okay, next one. Fractions. Those are scary, right? A lot of people are like, oh no, fractions, that one's hard. It's really not, okay? You're going to be okay. So let's go ahead and distribute. This time we have to distribute not just once, but twice. Okay, so the first time we're going to distribute 1/3 to the 18 and to the 12x. Then we're going to drop our equal sign and distribute the 6 to the 2x and the negative 7. So let's do it. So 1/3 times 18. This is just like 18 over 1, which makes this almost like a division problem, because that's only 1 times 18 is 18. 3 times 1 is 3. So 18 divided by 3 is 6. Okay, so if you don't know how to do that, I want you to go ahead and write out those skills, maybe look up some videos on multiplying fractions if you're still struggling with those, and then you could also use your calculator if you need to, okay, to check your answer. But try it in your head first. So then 1/3 times 12x, well, 1/3 of 12 is a positive 4, keep the x. Then 6 times 2 is 12x. 6 times negative 7 is negative 42. Okay, now I'm ready to send letters to one side, numbers to the other. So I'm going to look at my variables first, a positive 4x and a positive 12x. 4 is smaller, so I want to subtract that to move it to the other side. I'm going to join it with the 12, but since I go under the equal sign, I have to do the opposite sign. So that cancels. I'm left with 6 equals 12x minus 4x is 8x minus 42. Okay, then I'm going to add 42 to both sides. 6 plus 42 is 48 equals 8x. Then I'm going to divide by 8 on both sides, and I get 6 equals x. And that's your answer. Okay, so let's remind ourselves of a couple special cases that we sometimes have. Okay, it says let's look at these with and without a calculator. So if you have a calculator at home, you can definitely check your answer and see what it tells you. But if not, why is it not focusing? There we go. Okay, so if you do not have a calculator at home, there are plenty online that you can check your answers with and see what happens, or when you get here we'll definitely see what these look like in the calculator, because these are special cases and they look a little bit different. Okay, so let's go ahead and use our same steps just like we were doing the other problems and then see what happens that's different. So the first thing I see is I see some parentheses, so I need to hippity-hoppity, distributive property. So I'm going to drop everything that I don't use, drop it down. Then 3 times 5x is 15x. 3 times negative 4 is negative 12. And then I'm going to drop the negative 10x. Okay, now I need to see if there's any terms to combine. Are there any on that side? No, those aren't like terms. But we look over here. X, that means I need to combine those. So I'm going to drop everything else when I combine them. 5x plus 5 equals 15x minus 10x. Leaves me with 5x minus 12. Okay, now I'm going to move those x's to one side. So that's a positive 5x, so let me go ahead and subtract it. 5x minus 5x is gone. I'm left with 5 equals, whoa, 5x minus 5x. Didn't that just, whoop, become 0? So then I'm only left with negative 12 on that side. Is that a true or false statement? Does 5 equal negative 12? No, that is a false statement. So if you get a false statement, then your answer, if your variables go away and you get a false statement, then that means that, so if it has that 5 does not equal 12, then that means we would say the answer is no solution. And your calculator will tell you those. It'll say no solution when you do these ones. Okay, so that's one special case, is when we have no solution. So if our variables go away and we have a false statement. Okay, so let's look at when we have another scenario. So our calculator would tell us no solution, but it does a little something different with these. So let's see what happens here. So first we're going to hippity-hoppity distributive property, and we get 3 times 2b is 6b. 3 times negative 1 is negative 3. Negative 3 minus 7 equals 6b minus 10. Okay, so now we need to combine like terms on either side. So on this side we do have like terms. So we have 6b, negative 3 minus 7 is negative 10, equals 6b minus 10. Ooh, does those look similar to you? Let's keep going and see what happens. So we have minus 6b from one side, minus 6b from the other. Oh, 6b minus 6b is gone and leaves me with negative 10. 6b minus 6b is gone. It turns to 0 and leaves me with negative 10. Oh, that's a true statement. That checks out. So then that means if we get a true statement, then our answer is all real numbers. And depending on your calculator, it will show you different things. So we'll explore that whenever we get back. Okay, so just wanted you to remember that there's sometimes some special cases that you need to look at. So now let's look at these word problems. Oh no, word problems. Okay, so we're going to look at this. It says number 11 says the width of a rectangle is 16 less than twice the length. Let's just figure out the important stuff in that first sentence. So it says the width of a rectangle is 16 less than twice the length. So twice the length is going to be 2L less than is a switch word, so it means we start from the back and we go to the front, and less than would be a minus. So that first sentence gives us a paragraph, or a equation. It says width is 16 less than twice the width, so twice the length less than 16. Okay, then let's keep reading. Next sentence says, if the perimeter is 40 meters, find the length and width. So then my second equation is P equals 40. So that's the information that it gives me. So you should have at some point learned the formula for perimeter. And that formula is P equals 2L plus 2W. If you haven't learned it yet, please remember it. This is geometry, so we will need that. Okay, so we're going to take our information and we're going to plug it into what we know. So we know that P is 40. We're going to keep writing 2L. We don't know anything about L, plus 2, but we do know what W equals. It equals this over here. So we're going to slap down some parentheses and plug in what we know W equals. We're going to substitute that value in. 2L minus 16. Okay, now we're going to use our equation skills and everything's the same. We're going to hippity-hoppity, distributive property. 40 minus 2L plus 2 times 2L is 4L. 2 times negative 16 is negative 32. And then I need to combine like terms on the side, so I need to combine those L's together to give me 6L minus 32. Okay, then I'm going to send my numbers to the other side, so I'm going to add 32. So 40 plus 32 gives me 72 equals 6L. Bring that on up here. 72 equals 6L. And then I'm going to divide both sides by 6. And I get 72 divided by 6 is 12 equals L. So now I need to take that and I need to plug it back in to this to figure out my width. So I'm going to say width equals 2 times, I know what my length is now, so I'm going to plug that in, that 12 minus 16. So width equals 2 times 12 is 24 minus 16 is 8. So your length was 12, your width was 8. Okay, next problem. An online music service lets customers download an unlimited number of songs for 25 cents each. Each is an important word. It's a multiplication word. After paying a monthly membership fee of $5. In 1 month, Jaden spent $10.50 on music. Set up an equation to find how many X songs Jaden downloaded for that month. Okay, so hopefully you guys remember our Y equals MX plus B and how that helps us set up equations, because we know that M is a rate, and then with frequently the words per, each, and every, because they're multiplied. And then B is our y-intercept, or what we say our initial value. So it gives us that information. So let's just work with this side of this equation. It gives us a per, each, or every. It gives us a rate. So for every song, for each song, he's paying 25 cents. And so we're going to multiply it times the number of songs, which it told us was X. Okay, then I'm going to add on the initial value. Well, he paid a monthly fee of $5. So plus $5. Equals total amount that he spent in 1 month was $10.50. So now we can figure out how many songs that he downloaded that month. So we're going to get this term with the variable by itself first by subtracting that $5. That's gone. I'm left with 0.25x equals 1050 minus 5 is 550. And then we're going to divide both sides by 0.25. And we get x equals, you can put that in your phone calculator and it'll give you the answer, 22. So we can say Jaden downloaded 22 songs in 1 month. And that's your answer. All right, thanks, guys. There is an assignment that's going to be posted on this same page, so make sure you work it out. The best way for you to do it, so here's what it looks like. The best way for you to do this is going to be, if you can print it out, there's room for you to work it on here. If not, just number a piece of paper and write out your answers. I want to see your steps. You have to show your work on your paper or you will not get credit, okay? All right, see you guys next time.